So welcome to the second module of atoms and molecules. Today we'll be dealing about the concept of valency, writing chemical formulae of ionic compounds. So first of all, what is valency? Valency, it is the combining capacity of an element, and it can be determined by the charge present on the element. Okay. Here we will be studying about writing chemical formulae of ionic compounds. So what is meant by an ionic compound, that also we have to look off. Ionic compound is composed of two ions. Two ions, just like one cation and one anion. So cation is something which has got a positive charge and anion is something which has got a negative. It can be determined by the charge present on the element. And let us look at certain number of ionic compounds. So here we are studying actually the formula of ionic compounds with the help of this picture. Here you can see there are two pictures shown. First one is sodium. Just imagine that it is a sodium atom which is red in color, and in the sodium atom you are having certain number of, let me write the electronic configuration. Sodium, you know, sodium can be represented by Na, and Na has got the electronic configuration, the first shell 2, second shell 8, and the last shell 1 electron. So when according to the octet rule, when sodium has got this electronic configuration, what does it do? It always tries to lose one electron from the last shell. Okay, so this losing of one electron will make it perfectly an octet. That means 8 in the last shell. And if it loses one electron, what does it form? It will form a cation, Na plus cation. So here, by showing this one hand for sodium, we are actually thinking that there is one electron for it to give, and it can combine with something which is having one electron to take. So here, that is why we have drawn a chlorine atom. In the chlorine atom, you can see chlorine, the symbol is Cl. Chlorine has got the electronic configuration 2, 8, 7. So 287 means there are 7 electrons in the last shell. Okay, so it means in order to get the octet, what does the octet rule state? The octet rule states that there should be 8 electrons in the valence shell. Now it has to get one more electron to get the octet. So it is taking the electron and sodium is giving the electron. So it means when we try to write the valency of sodium, we write Na plus 1 because it is ready to give 1. Whereas chlorine, we can write only Cl minus 1 and we say it as chloride. Okay, because it is ready to take 1. So we means that it can combine with 1 1 and it can also combine with 1 1. So plus 1 and minus 1. It's a combining capacity of that element. Now if they two combine, what do they form? They form an ionic compound, that is Na and Cl will combine to form NaCl, sodium chloride. Okay, so in the same way, we will see some other compounds also. Let us take the next one. The next one which I am trying to represent is magnesium chloride. Okay, Mg, that is a symbol for magnesium, and its electronic configuration is 2, 8, 2. 282. So that means you have first shell 2 electron, second shell 8 electron, and the last shell you have got 2 electrons. Now in order to get the octet, that means in order to have the octet in the last shell, it has to give this 2 electrons it has to give. So it like this two hands it can be shown. So that means magnesium is actually having plus 2 to give out. Now suppose it has to form a compound with chlorine. You know chlorine has got 287. 287. So it can only take 1 because it has got one hand. So it can combine with the one hand of sodium. So what happens, in order to combine with the second hand of magnesium, just like sodium, another chlorine atom we have to take. Okay, so there will be two hands and it can combine with the next one because this one is also having 287. Okay, so actually for one chlorine atom it is Cl minus 1. For the other chlorine atom also it is Cl minus 1. But when we write the formula of this compound, in one molecule you have got one magnesium and two chlorine atoms. That is why the formula will be MgCl2. Now how can you write it easily? The way to write it easily is, without looking or without drawing this type of figures, you just look at the ionic formula. Okay, so magnesium has got +2 and chlorine has got -1. You can just exchange their formulas to write the valencies, to write their exact formula, that is MgCl2. Okay, so number 2 will go for chlorine and the 1 will come for magnesium. But 1 we are not writing here, especially like this we have to write. Otherwise we can write 1 is understood that it is 1. So we'll write MgCl2. That is a way of writing the formula of magnesium chloride. Okay, now let us look one more example. Now here I am trying to show you the compounds, what is aluminium and chlorine. So aluminium is having an electronic configuration 2, 8, 3. Okay, so first shell there are 2 electrons, second shell there are 8 electrons, and the last shell there are 3 electrons. So it means aluminium has to give away 3 electrons to become 8. Okay, so those all elements which have got less than 4, they will mostly lose the electrons to form the octet. So there are 3 hands shown here. It can combine or it can shake hands with 3 other hands. Let us take the example of chlorine itself. If you are making it up with chlorine, each chlorine has got 1 hand only. Okay, so 3 chlorines are required. So basically the formula for chlorine is Cl minus 1, and chloride it will become. When it becomes an ion, it will be called as chloride. So if I have to write the formula of aluminium chloride, what I can easily do is I'll take the formula of aluminium, which is +3, and then I'll take the formula of chloride, which is -1, and I will crisscross their valencies. Okay, so I'll take +3 and I'll take Cl -1 and I'll put this 1 here and I'll put this 3 here. So what will become? AlCl3, and thus this is the formula of aluminium chloride. Okay, so in this way you can write the chemical formula of ionic compounds. So in the last class we remember that we have studied the polyatomic ions, which is a group of atoms carrying a charge. There are polyatomic cations and polyatomic anions. There is a list of cations and anions which is given in your book, NCERT textbook, and these cations and anions we have to remember. The valencies are given on the top as a charge. Say for example ammonium, it has got +1. So if it is +1, it will not be written, but it should be understood as +1. Similarly, nitronium it is +1. Hydroxide, they are negative ions, OH -1. SO4 -2. So what is the valency here? Valency is -1. Here it is -2. What is the valency of carbonate? -2. Okay. So like that the valencies will be coming. Now let us try to write down the molecular formulae of certain ionic compounds. So I have given here some examples. First one is calcium oxide. Okay, now in order to write the formula of calcium oxide, first thing which has to come to our mind is the symbol of calcium and what is a valency. The valency is +2. What is oxygen? It is O, and -2 is a valency. Now earlier we have written for sodium chloride, magnesium chloride, aluminium chloride, etc. In the same way we can crisscross their valencies. So basically what you get when you crisscross the valency, you are having the same number, isn't it? Ca2O2. So like that it will come. So we write the simplest formula. So both numbers are same, means you divide them to get the simplest ratio. So 1:1 is the ratio. So the molecular formula will be CaO. CaO will be the molecular formula. Okay, so here actually we don't require the ions. Directly we can write it. What is the formula? CaO. Now next one is sodium oxide. So sodium, what is that? Na. Na is a symbol of sodium, and already you know, we have seen in the previous picture that Na is +1, and what about oxide? Oxide is -2. Okay, so that 2 from oxide will come to sodium, so it will become Na2, and oxide will get the 1, Na2O1, but there is no need of writing 1. Okay, so we will rub this 1. So what is the formula? The formula has become Na2O. So calcium oxide is CaO and sodium oxide is Na2O. Now let us look at aluminium oxide. So you know what is aluminium? Aluminium is +3 and oxide is -2. So aluminium is +3, so the 3 should go to oxygen and 2 should come here. So oxides 2 will come to here, Al2, and 3 of aluminium will go there, so it will become aluminium oxide, Al2O3. Next one is sodium nitride. Sorry, it is aluminium nitride. So aluminium, already we have written, what is that aluminium? Al, that is +3, and nitride N -3. So you can see here both are same. So if both are same, you can write the lowest ratio, that is AlN. That will be the formula, AlN. That is correct. Now let us look at some polyatomic ions. The polyatomic ions, it is first one given as sodium carbonate. Okay, so these are here the carbonate is a polyatomic ion. Okay, so I'll just write the valency one time. Na is +1 that we have studied, and carbonate is CO3. This is the formula of carbonate, and you have got the valency, that is 2 minus. So what will be your formula? The valency only you have to exchange. Formula will remain there itself. So 1 will come to this side and 2 will go to there. Okay, so what you have to write? Na 2, then CO3. No need of writing 1 because indicates that the CO3 together has got a 1 number. So since it is 1, there is no need of writing it again. Otherwise it would look like 31 and all, and there is no bracket required. So Na2CO3 is the formula of sodium carbonate. The next one is magnesium carbonate. So magnesium, you know magnesium is +2 and again carbonate is -2. So just like we have seen in the case of the first one, calcium oxide and aluminium nitride, if you get the same valencies, then there is no need of putting those numbers. It is understood as the lowest number is 1. So MgCO3, if you write, it is sufficient. MgCO3, that is a formula of magnesium carbonate. Magnesium hydroxide. Here you have to think that magnesium is +2 and hydroxide is OH, which is -1. Okay, so when we write Mg, you need to write 1. It is not required to write 1. Then you have to write OH. So here one number will come, isn't it? But here keep in mind that the 2, when you write it, it is not only for hydrogen, it is both for oxygen and hydrogen. So you need to put a bracket and then write twice. So what does it become? MgOH twice. Okay, so in this way we can write down the formulae of some ionic compounds. So this is a method. Let us write down some more formulas, that is for some different substances. The first one, copper oxide. Now here the examples which are given are having variable valencies. So what is given in the bracket, that is considered as a valency of that element. So copper 1 oxide, you will get Cu and it is +1. So O, you will write, this is 2, copper is 2 and oxide is 1. So Cu2O. Next one, silver 1 nitrate. Silver is Ag and it is 1 given, so +1, and next is nitrate is NO3, which is -1. Since both are +1 and -1, the formula is AgNO3. Next one is iron 2 oxide. So iron, what is the symbol? Fe. It is given 2. Oxide is also 2. So both are 2, 2. So ratio is 1:1. So FeO. Next one is zinc carbonate. So zinc, the symbol is Zn, and carbonate, the symbol is CO3. And as you know, zinc is +2 and carbonate is -2. Both are having same ratios, so you can write the formula as ZnCO3. Next one is sodium bicarbonate. Yes, Na is +1 and CO3 is -2. So you have got a different number. So what will be its formula? Na. Give the valency for the carbonate to sodium and write CO3. There is no need of writing 1. It's understood that CO3 is only 1 in number. So Na2CO3, that is the formula. Last one, aluminium nitride. So that's we have already written ALN. That is a formula for aluminium nitride. So here you can see so many ions, cations and anions. These all ions are given in your NCERT textbook. Some of them we have written. There are so many like sulfate and all. Its compounds you will have to practice by writing the different numbers. Okay. So one worksheet I will provide at the end of this one has a link. You can go through that and write down the answers to that. So thank you all of you.